Hello, I'd like to give you a update on my relay simulator. I've added some new features. The first feature is ground pins on relays. So I have my normal dual pole dual throw relay where the ground pin is omitted and it doesn't need it. But I now have a ground dual pole dual throw relay, which are these ones, which now have ground pins on the coils. This enables me to do more interesting switching. To give you an example, I'll start the simulator. Um, in this example here, if I apply power to the coils, you see the coils don't switch because the ground for these coils is not connected to anything. However, if I now turn on this relay with this enable relay, you can see now that the ground is now connected to the coils, which then allows the relays to switch. So using this technique, you can enable or disable banks of relays just by controlling whether the grounds are actually connected or not. The other improvement I've made is I've made a new relay type called latching relay. Here you can see a latching relay has two coils. If I energize this top coil, you can see that the contacts have changed. LEDA is now lit, but also you've noticed I've turned this coil off, and that the contact change has latched. It's staying permanently on A, and the only way to move it back is by energizing the second coil to latch it into its other state. The idea behind this is so I can generate, build a memory which will be persistent and not non-volatile memory for my relay computer. As an example, I've built this. This is a 2 byte memory. So as an example, I'll set 2 bits on the data bus here, and I'm going to write these 2 bits to byte 0. And if I click write, you can see that the bits are being written, and the write is actually controlling that those ground pins, allowing those relays to be connected to ground. So I'll turn that off, and I now write these 2 bits to byte 1. And I'll do that, and I do write, and you can see that again the write is controlling the ground wires to enable those relays. Now to read data back, I can select byte 0 again. This time I'll hit read, and you can see that these 2 pins, the D1 and D0, have now gone high. We can stop that, and on byte 1, if I hit read, you can see D2 and D3 have gone high. So this should be a direct kind of plug-in replacement for my 12-bit relay computer. The only thing I'm going to do is put a 3 to 8 line converter or 4 to 16 line converter on this side, and a lot more relays to build this memory. But the advantage is this would become non-volatile, so even when I power the machine off, the code that's stored in these bytes will remain until the next time I turn it back on, which I think should be quite useful.